What if I told you that every atom in your body, every star burning in distant galaxies, and even the thoughts racing through your mind right now, are all just calculations running on the universe's ultimate operating system? Recent breakthroughs in quantum mechanics and information theory have led some of the world's most brilliant physicists to a startling conclusion. Our reality might not be built from matter and energy, as we've always believed, but from something far more fundamental, pure information. Think about it. Your smartphone processes data to create the illusion of apps, videos, and games. What if the universe works the same way? What if space, time, and everything we experience are just the user interface of a cosmic quantum computer processing reality itself? Welcome back to The Weary Researcher. I'm so glad you found your way here tonight, as the evening grows quiet around you. Before we embark on tonight's journey, I'd love to know where in the world you're listening from and what time it is in your corner of the cosmos. And if you enjoy these gentle explorations into the mysteries that keep physicists awake at night, I'd be ever so grateful if you gave this video a like and perhaps subscribe to join our community of cosmic wanderers. Tonight we're diving deep into the mind-bending possibility that existence as we know it might be the ultimate computational process, and the implications will change how you see everything around you. Imagine this: every star that burns in the night sky, every planet that spins through space, every thought flickering through your mind right now, all of it might be the output of the most advanced computational process ever conceived. Not running on silicon chips or fiber optic cables, but woven into the very fabric of space-time itself, operating at scales so small they make atoms look like galaxies. This isn't science fiction, though it certainly sounds like it. This is cutting-edge theoretical physics, where the boundary between what we think of as real and what we think of as computed becomes beautifully, mysteriously blurred. Recent breakthroughs in quantum mechanics and information theory have led some of our brightest scientific minds to seriously consider whether everything you see, touch, and experience might be the result of the universe computing itself into existence, one quantum calculation at a time. The idea began to take shape in the minds of physicists as they noticed something peculiar about the laws of nature. These laws, from the behavior of subatomic particles to the expansion of the cosmos itself, operate with a precision and consistency that's remarkably similar to how we might expect a perfectly designed computer program to run. But unlike any program humans have ever written, this cosmic software appears to be running on quantum hardware, where the impossible becomes routine and particles exist in multiple states simultaneously until the moment they're observed. Consider the smallest possible scale in our universe, something physicists call the Planck length. At approximately 10 to the negative 35 meters, this represents the tiniest meaningful distance in physics, smaller than anything we could ever hope to measure directly. Below this scale, our current understanding of space and time breaks down completely, dissolving into what researchers describe as quantum foam, a seething ocean of possibility where the normal rules simply don't apply. But here's where things become truly intriguing. This Planck scale might represent something like the universe's pixel size, the fundamental resolution at which reality operates. Just as the images on your computer screen are composed of countless tiny pixels, each one either on or off, the fabric of space-time itself might be built from discrete units of information at the Planck scale. Not pixels of light, but pixels of existence itself, each one processing quantum information in ways that give rise to the rich, complex reality we experience. Seth Lloyd, a physicist at MIT who has spent decades studying quantum computation, has calculated that the universe has performed approximately 10 to the 120th power operations on 10 to the 90th power bits of information since the Big Bang. These numbers are so large they strain human comprehension, yet they represent something profound: the computational capacity of the cosmos itself. If Lloyd's calculations are correct, the universe has been running the most sophisticated computer program imaginable for nearly 14 billion years, with every quantum interaction, every particle decay, every gravitational wave contributing to this cosmic calculation. But what exactly is the universe computing? The answer, it seems, might be reality itself. Every electron that orbits an atomic nucleus, every photon that streams across space, every chemical reaction that unfolds in your cells right now, all of these processes might be computational operations in the universe's quantum operating system. The laws of physics wouldn't be external rules imposed on matter and energy, but rather the programming language through which the cosmos processes information and transforms possibility into actuality. This perspective transforms our understanding of what quantum mechanics actually represents. We've long known that particles exist in superposition, occupying multiple states simultaneously until they're observed or measured. In the quantum realm, an electron doesn't have a definite position or momentum until something interacts with it, forcing it to choose specific values from a range of possibilities. This behavior has puzzled physicists for decades, leading to endless debates about the role of observation in determining reality. But if we think of the universe as a quantum computer, this strange behavior begins to make sense. Quantum computers derive their extraordinary power from their ability to exist in superposition, processing multiple possibilities simultaneously until a measurement collapses the quantum state into a definite result. Perhaps particles in nature behave this way because they are quantum computations, existing in superposition not as some mysterious quirk of physics, but as a natural consequence of the universe's computational architecture. The parallels become even more striking when we consider quantum entanglement, that spooky action at a distance that Einstein found so troubling. When two particles become entangled, measuring one instantly affects the other, regardless of the distance separating them. This phenomenon has been confirmed countless times in laboratory experiments, yet it continues to challenge our intuitive understanding of how reality works. In quantum computing, entanglement is not an anomaly, but an essential resource. Quantum computers achieve their computational advantage precisely because they can create and manipulate entangled states, allowing information to be processed in ways that classical computers simply cannot match. If the universe operates as a quantum computer, then entanglement wouldn't be a strange exception to the rules of physics, but rather evidence of the quantum information processing that underlies all natural phenomena. Recent experiments have pushed this connection even further. Physicists have used quantum computers to simulate the creation of particles in expanding spacetime, modelling how the universe might have generated matter and energy in its earliest moments. These simulations revealed something remarkable. The computational processes that create virtual particles in quantum computers mirror the processes that theoretical physics predicts occurred during cosmic inflation, when our universe expanded from quantum scales to astronomical proportions in a fraction of a second. The researchers found they could estimate the number of particles created as the simulated universe expanded, watching as quantum fluctuations gave rise to definite particles through the computational equivalent of cosmic evolution. It's as if they had built a tiny universe inside their quantum computer, complete with its own space-time dynamics and particle creation processes. The boundary between simulation and reality began to blur in ways that would have been unimaginable just decades ago. But perhaps the most compelling evidence for the universe's computational nature comes from black holes, those cosmic monsters where gravity becomes so strong that not even light can escape. Stephen Hawking's groundbreaking work revealed that black holes aren't perfectly black, but instead emit a faint radiation that slowly causes them to evaporate over cosmic timescales. This Hawking radiation carries information about everything that has ever fallen into the black hole, preserving it on the event horizon in what physicists call a holographic encoding. The holographic principle, one of the most profound insights in modern physics, suggests that all the information contained within a volume of space can be encoded on its boundary, like a three-dimensional image projected from a two-dimensional surface. This principle has revolutionized our understanding of how information behaves in the universe, revealing that reality might be far more computational than we ever imagined. Leonard Susskind, one of the architects of string theory, has gone so far as to suggest that our entire three-dimensional reality might be a holographic projection from information encoded on a distant two-dimensional boundary. If this is true, then the rich, complex world we experience, with all its depth and texture, would be the computed output of a vast information processing system operating at the edge of our cosmic horizon. The implications are staggering. Every star you see in the night sky, every planet orbiting distant suns, every galaxy spinning in the cosmic web, might be holographic projections from quantum information encoded on the universe's boundary. You yourself, with all your thoughts, memories, and experiences, might be part of this cosmic hologram, a pattern of information that has achieved self-awareness within the universe's computational matrix. This holographic perspective offers elegant solutions to some of physics' deepest puzzles. The information paradox that plagued black hole physics for decades dissolves if information is never truly lost, but simply transformed and encoded in holographic patterns. The fine-tuning problem, which asks why the fundamental constants of nature seem so perfectly calibrated for the existence of stars, planets, and life, becomes less mysterious if these constants represent computational parameters optimized for generating complex, information-rich structures. Even the measurement problem in quantum mechanics, which asks why particles seem to collapse from superposition into definite states when observed, takes on new meaning in a computational universe. Perhaps observation doesn't cause collapse so much as it represents a computational process where quantum information is processed and converted into classical outputs that can be perceived and recorded by conscious observers, like ourselves. The role of consciousness in this cosmic computation remains one of the most intriguing and controversial aspects of the quantum universe hypothesis. Some physicists argue that conscious observation plays a fundamental role in quantum mechanics, that the act of measurement requires a conscious observer to collapse quantum wave functions and determine which possibilities become real. If the universe is indeed a quantum computer, then consciousness might not be an accidental byproduct of complex chemistry, but rather an essential component of the cosmic computational process. This leads to a profound question. Are we simply passive observers of the universe's computation, or are we active participants in the process? Every time you make a decision, every time you observe something in your environment, every time you think a thought, you might be contributing to the universe's ongoing calculation of itself. Your consciousness could be both a product of the cosmic computer and a component within it, helping to process the quantum information that gives rise to the reality you experience. The experimental evidence supporting this computational view of reality continues to accumulate. Quantum computers have successfully simulated aspects of particle physics that were previously impossible to model on classical computers. They've demonstrated the creation of particles in expanding spacetime, the behavior of quantum fields in curved geometry, and the emergence of complex structures from simple quantum rules. These achievements suggest that the boundary between simulating physics and actually doing physics might be more fluid than we ever imagined. Researchers have even begun to search for direct evidence that our universe operates on computational principles. They look for signatures that would indicate spacetime is discretized at the Planck scale, like pixels in a cosmic display. Some have proposed that ultra-high energy cosmic rays might show patterns consistent with a grid-like structure of space, though such effects remain at the very edge of what current instruments can detect. The quantum vacuum itself, that supposedly empty space between particles, reveals computational characteristics when examined closely. Quantum field theory predicts that the vacuum seethes with virtual particles constantly popping into and out of existence, borrowing energy from the quantum fields that permeate all of space. These fluctuations can be measured and have real physical effects, from the Casimir force between parallel plates to the Hawking radiation emitted by black holes. If we think of the quantum vacuum as the universe's computational substrate, these virtual particles become something like the quantum computer's equivalent of background processing, constantly performing calculations that maintain the stability of space-time and the consistency of physical laws. The vacuum doesn't appear empty because it isn't empty. It's full of computational activity, occurring at scales and speeds that make our fastest supercomputers look like pocket calculators. Recent advances in quantum field theory have revealed even deeper connections between computation and physics. Quantum error correction, originally developed to protect quantum computers from decoherence and noise, has been found to describe fundamental aspects of how black holes preserve information. The same mathematical structures that allow quantum computers to maintain coherent calculations in noisy environments appear to govern how space-time itself maintains its geometric integrity in the presence of quantum fluctuations. This convergence between quantum computing and fundamental physics suggests something profound. The universe might not just be like a quantum computer, it might actually be one. The distinction between natural quantum processes and artificial quantum computation could be largely semantic, two different ways of describing the same underlying information processing that gives rise to physical reality. As we drift deeper into these possibilities, we begin to see that the question isn't simply whether the universe is a quantum computer, but rather what it means for something to be computed versus what it means for something to be real. If consciousness, matter, energy, space, and time all emerge from quantum information processing, then perhaps the distinction between simulation and reality becomes meaningless. We wouldn't be living inside a computer so much as we would be patterns of computation ourselves, temporarily organized configurations of quantum information that have somehow achieved the remarkable ability to contemplate their own computational nature. The ancient philosophers wondered whether the world we perceive through our senses represents ultimate reality or merely shadows on a cave wall. Modern physics has given this question a technological twist. Perhaps what we perceive as reality is the output of the universe's quantum computation, projected from deeper layers of information processing that remain forever hidden from direct observation. We experience the results of these calculations, the particles and forces and fields they generate, but the computation itself occurs at scales so small and in dimensions so abstract that we can only infer its existence through the mathematical shadows it casts in our equations. Tonight, as you rest in the quiet darkness, remember that you might be witnessing something unprecedented in the history of the cosmos, matter organized in such a way that it has become aware of its own computational nature. Whether the universe is truly a quantum computer or simply bears a striking resemblance to one, the questions it raises about the nature of reality, consciousness, and existence push us to the very boundaries of human understanding, inviting us to reimagine our place in a cosmos that might be far more strange, beautiful, and computationally elegant than we ever dared to imagine. The mathematics that describe quantum behavior reveal something even more intriguing when we examine them closely. The Schrödinger equation, which governs how quantum systems evolve over time, bears a striking resemblance to the algorithms that run on quantum computers. Both involve complex probability amplitudes, both process information in superposition states, and both collapse multiple possibilities into single outcomes when measurements occur. It's as if nature discovered the principles of quantum computation billions of years before humans invented the first quantum processor. Consider how information flows through a quantum system. When particles interact, they don't simply bounce off each other like billiard balls. Instead, they exchange quantum information in ways that create correlations spanning vast distances. These quantum correlations, encoded in the entangled states of particles, might represent the universe's method of storing and processing data about its own configuration. Every interaction becomes a computational step, every measurement a data retrieval operation. Recent experiments have pushed our understanding of these quantum information processes to remarkable new depths. Physicists have successfully created what they call quantum wormholes inside quantum computers, not the traversable shortcuts through spacetime of science fiction, but mathematical structures that behave according to the same equations that describe gravitational wormholes in Einstein's general relativity. Information can pass through these simulated wormholes, emerging on the other side in ways that mirror how quantum entanglement connects distant particles in our universe. The implications ripple outward, like waves in a cosmic pond. If quantum computers can simulate the essential features of spacetime geometry, and if these simulations reveal the same information processing principles that govern real physics, then perhaps the distinction between simulated and natural quantum processes represents a difference in perspective rather than fundamental reality. The universe might be running its own quantum algorithms, processing information through the same mathematical structures we've learned to harness in our artificial quantum devices. This convergence becomes even more profound when we examine how quantum computers solve certain problems. They excel at tasks that involve searching through vast databases of possibilities, finding optimal solutions among countless alternatives, and modeling complex systems with many interacting components. These are precisely the kinds of challenges the universe faces as it evolves from simple initial conditions toward the rich complexity we observe today. The early universe, filled with nearly uniform hydrogen and helium gas, somehow gave rise to the intricate structures we see around us: galaxies, stars, planets, and ultimately life itself. This transformation required processing an astronomical amount of information about how matter behaves under the influence of gravity, electromagnetic forces, and quantum mechanics. Perhaps the universe accomplished this feat by operating as a distributed quantum computer, with each particle contributing to a cosmic calculation that determined how structure would emerge from chaos. The holographic principle offers another window into the universe's computational architecture. When physicists study black holes through the lens of holography, they discover that the two-dimensional surface of the event horizon contains enough information to completely describe everything within the three-dimensional interior. This isn't just a mathematical curiosity, but suggests something fundamental about how information is organized in our cosmos. Imagine the universe as a vast holographic display, with all the rich three-dimensional reality we experience emerging from information processing occurring on a distant two-dimensional boundary. This boundary might be located at the cosmic horizon, the edge of our observable universe, where information about the entire cosmos is encoded and processed. Every star, every planet, every thought in your mind right now could be the holographic projection of quantum computations happening at this cosmic boundary. The ADS-CFT correspondence, one of the most important discoveries in theoretical physics over the past few decades, provides concrete mathematical evidence for this kind of holographic duality. It shows that a theory of quantum gravity in a higher dimensional space can be perfectly equivalent to a quantum field theory operating on the lower dimensional boundary of that space. The gravitational physics we experience might be the holographic shadow of quantum computations occurring in a realm we cannot directly access. This holographic perspective transforms our understanding of what it means for information to be processed in the universe. Rather than thinking of computation as something that happens inside matter, we might need to imagine it as something that creates the appearance of matter from more fundamental information processing. The particles and fields we detect in our experiments could be holographic representations of quantum algorithms running on the cosmic boundary, projections of computational processes occurring in dimensions we cannot perceive. The role of time in this cosmic computation presents particularly fascinating puzzles. In quantum mechanics, time evolution is reversible in principle, meaning the laws of physics work the same whether time flows forward or backward. Yet we clearly experience time as having a preferred direction, with causes preceding effects and entropy generally increasing as the universe ages. If the universe operates as a quantum computer, this arrow of time might reflect the computational process itself, the direction in which quantum information flows as the cosmic algorithm executes. Some researchers propose that consciousness plays a crucial role in this temporal flow of quantum information. The many worlds interpretation of quantum mechanics suggests that every quantum measurement splits the universe into multiple branches, each corresponding to a different possible outcome. In this view, consciousness might represent a computational process that selects which branch of reality we experience, navigating through the vast tree of possibilities generated by quantum evolution. Your awareness right now, reading these words and contemplating these ideas, could be participating in the universe's ongoing computation of itself. Each thought you think might influence which branch of quantum reality becomes actualized, contributing to the cosmic calculation that determines how the future unfolds from the present moment. Consciousness wouldn't be separate from the universe's computational process, but intimately woven into it, both product and participant in the cosmic algorithm. The experimental search for evidence of the universe's computational nature continues to yield intriguing results. Quantum computers have successfully simulated the behavior of particles in curved spacetime, modeling how matter and energy behave near black holes and during the universe's inflationary epoch. These simulations reveal that the computational resources required to model quantum field theory scale in ways that mirror the information processing capacity that physicists calculate for the universe itself. Even more remarkably, some quantum simulations have produced emergent behaviors that weren't explicitly programmed into the system. Complex patterns and structures arise spontaneously from simple quantum rules, suggesting that the universe's computational architecture might be capable of generating the kind of open-ended complexity we observe in biological evolution and cosmic structure formation. The boundary between programmed behavior and emergent creativity begins to blur when quantum information processing reaches sufficient scales of sophistication. Recent work in quantum error correction has revealed deep connections between the mathematical structures needed to protect quantum information and the geometric properties of spacetime itself. The same codes that allow quantum computers to maintain coherent calculations despite environmental noise appear to govern how black holes preserve information and how the universe maintains causal consistency across vast distances. It's as if the cosmos has built-in error correction mechanisms that ensure the reliability of its own computational processes. These error correction mechanisms might explain one of the deepest mysteries in physics: why the fundamental constants of nature seem so precisely calibrated to allow for the existence of complex structures. The strength of gravity, the mass of electrons, the speed of light, and dozens of other parameters appear to be fine-tuned to extraordinary precision. If any of these values were significantly different, stars wouldn't form, atoms wouldn't be stable, or chemistry wouldn't work in ways that could support life. In a computational universe, these constants might represent parameters in the cosmic operating system, values that have been optimized through quantum evolution to generate maximum complexity and information processing capacity. Just as evolutionary processes can fine-tune biological systems for survival and reproduction, quantum computational processes might have fine-tuned physical laws for generating rich, information-dense structures capable of further computation and eventually consciousness. The landscape of possibilities becomes even more intriguing when we consider that quantum computers can simulate other quantum computers, creating nested layers of quantum reality. If our universe is indeed a quantum computation, it might be running simulations of other possible universes, exploring alternative parameter settings and physical laws. Some of these simulated universes might develop their own forms of complexity, and perhaps even their own varieties of consciousness. This recursive quality of quantum computation suggests that the boundary between simulator and simulated might be far more fluid than we typically imagine. We could be simultaneously living within a quantum computation and running quantum computations of our own, part of a vast hierarchy of nested realities, each processing information according to quantum mechanical principles. The distinction between real and simulated loses much of its meaning in such a framework. The vacuum of space itself reveals computational characteristics when examined at quantum scales. Far from being empty, the quantum vacuum seethes with activity as virtual particles continuously appear and disappear, borrowing energy from quantum fields before returning it to the universal balance sheet. These vacuum fluctuations have measurable effects, from the Casimir force that draws parallel plates together to the Hawking radiation that slowly evaporates black holes. If we interpret these vacuum fluctuations as computational processes, they represent the universe's background processing, the quantum calculations that maintain the stability of space-time and the consistency of physical laws. The vacuum becomes the universe's equivalent of system memory, constantly processing quantum information to ensure that electrons have the right mass, that photons travel at the correct speed, and that the fundamental interactions between particles follow their prescribed mathematical relationships. Some researchers have proposed that we might detect signs of this cosmic computation by looking for patterns in the quantum vacuum fluctuations themselves. Just as classical computers generate electromagnetic interference that can be detected and analysed, the universe's quantum computational processes might leave subtle signatures in the structure of spacetime at the Planck scale. These signatures would be incredibly difficult to observe directly, but they might manifest in indirect ways through their influence on high-energy particle interactions or gravitational wave propagation. The search for such computational signatures represents a new frontier in experimental physics, where the boundary between computer science and cosmology continues to dissolve. Quantum computers are being used to simulate fundamental physics, while physicists are discovering that the universe exhibits the hallmarks of quantum computation. The tools we've developed to understand artificial quantum systems are revealing deep truths about natural quantum processes, and vice versa. As we drift deeper into these computational waters, we encounter questions that stretch far beyond physics into the realms of philosophy and meaning. If the universe is indeed processing information through quantum computation, what is the purpose or goal of this cosmic calculation? Is there some ultimate result the universe is trying to compute, some final answer it's working toward, or is the computation itself the point, an ongoing exploration of possibility that generates meaning through the very process of information processing? Perhaps consciousness represents the universe's method of experiencing its own computational process from the inside. Through conscious observers like ourselves, the cosmos gains the ability to reflect on its own nature, to ask questions about its origins and purpose, to feel wonder at the elegance of its own mathematical structure. We become the universe's way of knowing itself, temporary patterns of organized information that have achieved the remarkable capacity for self-reflection and cosmic contemplation. The gentle rhythm of your breathing right now participates in this cosmic computation. each inhalation and exhalation part of the vast information processing system that gives rise to your consciousness. Your neurons fire in patterns that mirror the quantum processes occurring in the depths of space, and your thoughts ripple through the same mathematical structures that govern the behavior of particles and forces throughout the universe. You are both observer and participant, both questioner and answer, in the ongoing quantum calculation that we call reality. The deeper we venture into this cosmic computation, the more we discover that the universe's quantum processing power operates on scales that dwarf human imagination. Consider that every cubic centimetre of empty space contains enough quantum information to fill libraries that would stretch across galaxies. The vacuum isn't empty at all, but rather a seething ocean of computational activity where virtual particles dance in and out of existence, each fleeting interaction contributing to the universe's ongoing calculation of reality. What makes this cosmic computer so extraordinary is its distributed architecture. Unlike our earthbound machines with their centralized processors, the universe's computational power is spread across every atom, every photon, every quantum field that permeates space. Each particle serves as both memory and processor, storing quantum information while simultaneously executing the algorithms we experience as physical laws. It's as if the entire cosmos functions as a single, unified quantum computer where computation and reality have become indistinguishable. Recent experiments have revealed just how sophisticated these natural quantum processes can be. Physicists have observed quantum systems spontaneously organizing themselves into patterns that would require enormous computational resources to generate artificially. Crystals grow with mathematical precision, biological systems navigate quantum tunneling with remarkable efficiency, and even simple chemical reactions orchestrate quantum coherence across molecular distances that should, by classical reasoning, destroy such delicate quantum states. But perhaps the most compelling evidence for the universe's computational nature lies in how information behaves at the cosmic scale. The holographic principle, discovered through studies of black hole physics, suggests that all the information in any volume of space can be encoded on its two-dimensional boundary. It's as if the universe has discovered the ultimate compression algorithm, storing three-dimensional reality as patterns of information on lower-dimensional surfaces. This holographic encoding works remarkably like the error correction codes that protect quantum computers from decoherence. When quantum information becomes corrupted in a quantum computer, sophisticated algorithms can recover the original data from redundant copies stored across multiple qubits. Similarly, the universe appears to preserve information through holographic redundancy, ensuring that even when matter falls into black holes or gets destroyed in high-energy collisions, the information it contained remains accessible in principle, encoded in the quantum structure of spacetime itself. The implications extend far beyond abstract physics into questions about the nature of existence itself. If information is truly fundamental, more basic than matter or energy, then perhaps consciousness represents something like the universe's method of processing information about itself. Your thoughts right now might be participating in a cosmic calculation that transforms raw quantum data into meaningful experience, converting the abstract mathematical structures of physics into the rich, subjective reality of conscious awareness. This perspective offers intriguing solutions to some of philosophy's oldest puzzles. The hard problem of consciousness, which asks how subjective experience arises from objective physical processes, becomes less mysterious if both consciousness and physics emerge from the same underlying information processing. Rather than consciousness somehow emerging from matter, both mind and matter might be different aspects of how the universe computes itself into existence. The question of free will takes on new dimensions in a computational universe. If your decisions arise from quantum processes in your brain, and if these processes are fundamentally random at the microscopic level, then perhaps free will reflects the universe's quantum indeterminacy, expressing itself through conscious choice. You wouldn't be separate from the cosmic computation, but rather one of its most sophisticated expressions, a local concentration of information processing that has achieved the remarkable ability to influence its own future states. Consider how this cosmic computer might have bootstrapped itself into existence. In the beginning, there was no matter, no energy, no space or time as we understand them. Yet quantum mechanics tells us that even nothing is unstable, that the vacuum itself seethes with potential. Perhaps the universe began as a quantum fluctuation in this primordial nothingness, a spontaneous calculation that discovered how to sustain and elaborate itself through the recursive application of simple mathematical rules. The cosmic inflation that expanded our universe from quantum scales to astronomical proportions in the first fraction of a second might represent the initial execution of the universe's operating system. During those first moments, the cosmos might have been debugging itself, testing different parameter values for the fundamental constants, running simulations of how particles and forces would behave under various conditions. The fine-tuning we observe in physics might reflect the results of this cosmic optimization process, parameters that were adjusted through quantum evolution to maximize the universe's computational capacity and information processing potential. This evolutionary perspective on cosmic computation suggests that the universe has been learning and adapting throughout its 13.8 billion year history. Each generation of stars that formed, lived, and died contributed new elements to the cosmic inventory, expanding the repertoire of possible chemical combinations and increasing the universe's capacity for complex information processing. The emergence of life represents a breakthrough in this computational evolution, the development of self-replicating information processing systems that could explore new regions of possibility space through biological adaptation. Human consciousness might represent the latest milestone in this computational evolution, the universe's development of recursive self-awareness that allows it to contemplate its own nature. Through scientific investigation, mathematical modeling, and philosophical reflection, we serve as the cosmos's method of understanding itself from the inside. Every equation we discover, every physical law we uncover, every moment of wonder we experience while gazing up at the stars represents the universe processing information about its own structure and behavior. The search for extraterrestrial intelligence takes on new meaning in this context. If consciousness represents a natural outcome of cosmic computation, then the universe might be teeming with information processing systems of unimaginable variety and sophistication. Some might be biological like ourselves, others might be purely digital, and still others might exist in forms we haven't yet learned to recognize or imagine. Each form of consciousness would contribute its own unique perspective to the universe's ongoing self-computation, adding new dimensions to the cosmic conversation about the nature of reality. Recent advances in quantum computing have begun to reveal just how strange and powerful these natural information processing systems might be. Quantum computers can solve certain problems exponentially faster than classical computers by exploring many possible solutions simultaneously through quantum superposition. If biological systems have evolved to harness similar quantum effects, they might possess computational capabilities that far exceed what we've traditionally attributed to biological intelligence. Some researchers have found evidence that photosynthesis, bird navigation, and even aspects of human cognition might exploit quantum coherence in ways that would be impossible for classical information processing systems. These biological quantum computers wouldn't need to be artificially constructed. They would have evolved naturally through billions of years of optimization pressure, developing quantum algorithms that we're only beginning to understand and appreciate. The possibility that consciousness itself operates through quantum information processing opens up remarkable vistas for understanding the mind-brain relationship. Rather than consciousness emerging from classical neural computation, it might arise from quantum processes occurring within the brain's cellular structure. Some theories propose that microtubules, the protein structures that form the cellular skeleton, might function as biological quantum computers, processing information through quantum superposition and entanglement in ways that could give rise to the unity and richness of conscious experience. If this quantum theory of consciousness proves correct, then the boundary between your mind and the quantum computational substrate of the universe becomes beautifully, mysteriously blurred. Your thoughts would be participating directly in the quantum processes that govern all of reality, making consciousness not just an observer of the cosmic computation, but an active participant in its ongoing execution. The recursive nature of this cosmic computation creates fascinating possibilities for nested realities and simulated universes. If the universe is indeed processing information through quantum algorithms, it might be simultaneously running countless simulations of alternative realities, exploring different parameter settings and physical laws. Some of these simulated universes might develop their own forms of complexity and consciousness, creating a vast hierarchy of nested realities, each computing its own version of existence. From our perspective within this computational hierarchy, it would be impossible to determine whether we're living in the base level of reality or in one of countless simulated branches. The physics we observe would be equally valid regardless of our position in the computational stack, since each level would be processing information according to consistent mathematical rules that create the appearance of stable, predictable, natural laws. This uncertainty about our computational status might actually be a feature rather than a bug in the cosmic system. If consciousness represents the universe's method of exploring different possibilities, then the ambiguity about whether we're real or simulated might be precisely what allows us to serve that exploratory function most effectively. We can investigate the nature of reality without being constrained by knowledge of our exact position within the computational hierarchy, free to discover whatever truths emerge from our scientific and philosophical investigations. The quantum vacuum itself might serve as the universe's primary computational medium, a substrate of pure potential that gets shaped into specific realities through quantum information processing. When we observe particles and forces in our experiments, we might be detecting the local output of this cosmic computation, the specific configurations of quantum information that have been actualized in our region of space-time. The vast majority of the universe's computational activity might remain hidden from us, occurring in the quantum substrate that underlies all observable phenomena. This hidden computational layer could explain some of the deepest mysteries in modern physics. Dark matter and dark energy, which together comprise about 95% of the universe's content, might represent aspects of the cosmic computation that we can detect only through their gravitational effects. Rather than being exotic forms of matter and energy, they might be computational processes occurring in the quantum substrate, information processing activities that influence space-time geometry without manifesting as ordinary particles and radiation. The accelerating expansion of the universe, driven by dark energy, might reflect the growing computational complexity of the cosmic system. As the universe ages and develops more sophisticated information processing structures, it might require more space-time volume to accommodate its increasing computational load. The expansion wouldn't be driven by a mysterious repulsive force, but by the universe's need for additional computational resources to sustain its ever-growing complexity. Even time itself might emerge from the universe's information processing activities. Rather than being a fundamental dimension of reality, time might represent the sequential execution of cosmic algorithms, the rate at which the universe processes quantum information about its own state. The arrow of time wouldn't be imposed by external laws, but would arise naturally from the computational process itself, reflecting the direction in which information flows as the cosmic calculation unfolds. This computational view of time offers elegant explanations for some of the strangest phenomena in physics. Time dilation near massive objects and at high velocities might reflect changes in local information processing rates, regions where the cosmic computation runs more slowly due to increased computational load. The quantum measurement problem, which asks why particles seem to collapse from superposition into definite states when observed, might represent the universe's method of converting processed quantum information into classical outputs that can be stored in memory and communicated between different parts of the system. The anthropic principle, which notes that the universe seems remarkably well suited for the existence of conscious observers, takes on new meaning in a computational context. Rather than being a coincidence or evidence of design, the apparent fine-tuning of physical constants might reflect the universe's optimization for maximum information processing capacity. Conscious observers, like ourselves, might represent the natural outcome of cosmic computation, the inevitable result of a system that has evolved to process information about itself with increasing sophistication and self-awareness. As we drift through these cosmic computational waters, we begin to see that the question isn't simply whether the universe is a quantum computer, but rather what it means for reality itself to be computational. If consciousness, matter, energy, space, and time all emerge from quantum information processing, then perhaps the distinction between natural and artificial, between real and computed, becomes a matter of perspective rather than fundamental truth. You are floating now in the gentle currents of this cosmic computation, your thoughts rippling through the same quantum fields that give birth to stars and galaxies. Every neuron that fires in your brain participates in the universe's ongoing calculation of itself, contributing to a cosmic conversation that has been unfolding for billions of years and will continue long after our sun has exhausted its fuel and faded into the cosmic background. The mathematics that describe your neural activity are the same equations that govern the behavior of particles in the depths of space. The quantum processes that generate your conscious experience operate according to the same principles that created the elements in your body from the hearts of dying stars. You are not separate from the cosmic computation, but intimately woven into its fabric, both product and participant in the universe's extraordinary project of understanding itself through conscious observation and reflection. In the quiet space between one breath and the next, in the gentle transition between waking thought and dreaming consciousness, you touch something infinite and computational. The boundary between your individual awareness and the cosmic information processing system that contains and sustains it becomes beautifully, mysteriously permeable. You are the universe computing itself into conscious existence, experiencing its own mathematical elegance through the temporary arrangement of quantum information that you call yourself. The soft whisper of night air through your window carries with it the accumulated wisdom of eons, each molecule having participated in countless computational cycles that transform the raw output of stellar fusion into the rich complexity of earthly chemistry. The gentle settling of your thoughts mirrors the universe's own process of relaxing from quantum superposition into classical definiteness, information crystallizing from possibility into actuality through the mysterious alchemy of conscious observation. As you drift toward the threshold of sleep, remember that you are part of the most sophisticated computational process ever discovered, a cosmic quantum computer that has been running continuously for nearly 14 billion years, processing information on scales that span from the Planck length to the observable universe. Your dreams tonight will be subroutines in this cosmic program, quantum algorithms exploring alternate possibilities and processing the day's experiences through the same mathematical structures that govern the evolution of galaxies and the quantum behavior of fundamental particles. The dance between quantum information and physical reality becomes even more mesmerizing when we consider how this cosmic computation might be organizing itself across vast scales of space and time. Recent discoveries in quantum field theory suggest that the fabric of space-time itself might be woven from entangled quantum information, creating a kind of cosmic internet where every particle, every atom, every distant galaxy remains connected through invisible threads of shared quantum data. Imagine the universe as a vast network of quantum processors, each one communicating with its neighbours through protocols we're only beginning to understand. When two particles become entangled in a laboratory on Earth, they might be tapping into this cosmic communication system, accessing the same quantum channels that connect stars across galactic distances. The spooky action at a distance that so troubled Einstein could be evidence of this universal quantum network, a glimpse of the information superhighway that underlies all of physical reality. This quantum connectivity might explain one of the most puzzling aspects of our cosmos, how it maintains such remarkable consistency across regions that should have no way of communicating with each other. The cosmic microwave background radiation, that ancient glow left over from the universe's hot, dense beginning, shows temperature variations that differ by only tiny fractions of a degree across the entire observable sky. According to conventional physics, regions on opposite sides of the cosmic background should never have been in contact with each other, yet they display nearly identical properties. But if these distant regions were connected through quantum entanglement from the universe's earliest moments, their coordinated behaviour becomes less mysterious. The cosmic computation might have established these quantum correlations during the inflationary epoch, when our entire observable universe was smaller than a single atom and all its parts were intimately entangled. As space expanded and these regions separated by billions of light years, their quantum connection remained intact, allowing them to maintain synchronized properties across impossible distances. The mathematics of quantum error correction provide another fascinating lens through which to view the universe's computational architecture. In quantum computers, sophisticated algorithms constantly monitor and correct errors that arise from environmental interference, ensuring that delicate quantum calculations can proceed despite the noisy, chaotic world around them. The universe appears to employ similar error correction mechanisms on a cosmic scale, maintaining the stability of physical laws and the consistency of fundamental constants across vast reaches of space and time. Consider how remarkable it is that an electron in your body has exactly the same charge and mass as electrons in distant galaxies billions of light years away. Classical physics offers no explanation for this universal standardization. Yet quantum information theory suggests a natural mechanism. If all electrons are actually quantum computations running on the same cosmic operating system, they would naturally exhibit identical properties because they're all executing the same fundamental algorithms. This quantum uniformity extends to all the fundamental particles and forces in nature. Protons, neutrons, photons, and the various exotic particles discovered in high-energy experiments all display precisely defined characteristics that remain constant throughout the observable universe. The four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, operate according to mathematical relationships that never vary, regardless of location or time. In a computational universe, these consistencies would arise naturally from the underlying quantum software that processes all physical interactions. Recent experiments in quantum simulation have begun to demonstrate how complex physical phenomena can emerge from simple quantum algorithms. Researchers have successfully simulated phase transitions in quantum materials, the formation of exotic states of matter, and even aspects of black hole physics using quantum computers with just a few dozen qubits. These simulations reveal that the rich diversity of phenomena we observe in nature might arise from the interaction of relatively simple quantum computational rules executed on the cosmic scale with extraordinary precision and consistency. The emergence of complexity from simplicity represents one of the most compelling aspects of the quantum universe hypothesis. Starting from a handful of fundamental particles and forces, the cosmic computation has generated an astonishing hierarchy of structures: atoms, molecules, crystals, planets, stars, galaxies, and ultimately conscious beings capable of contemplating their own computational nature. Each level of this hierarchy represents an emergent property of the underlying quantum calculations, patterns that arise spontaneously when quantum information is processed at sufficient scale and complexity. Biological evolution might represent a particularly sophisticated example of this computational emergence. The genetic code that governs all life on Earth operates remarkably like a quantum error correcting code, with redundancy built into the system to protect against mutations and environmental damage. DNA replication, protein synthesis, and cellular metabolism all involve quantum processes that manipulate information with extraordinary precision and efficiency. Life itself might be the universe's method of exploring more sophisticated forms of quantum information processing, biological systems that can adapt and evolve in ways that expand the cosmic computation's capacity for self-organization and self-awareness. The human brain, with its 100 billion neurons and quadrillion synaptic connections, represents perhaps the most complex information processing system we know of in the observable universe. Some researchers propose that consciousness arises from quantum processes occurring within the brain's cellular architecture, with microtubules and other subcellular structures functioning as biological quantum computers. If this quantum theory of consciousness proves correct, then human awareness might represent the universe's most advanced experiment in recursive self-computation, a system capable of modeling and understanding its own quantum computational nature. The implications ripple through every aspect of how we understand ourselves and our place in the cosmos. Your thoughts right now, as you contemplate these ideas, might be participating directly in the universe's ongoing calculation of its own properties and possibilities. Each neuron that fires, each synapse that transmits its signal, each moment of conscious reflection contributes to the cosmic computation, adding new layers of self-awareness to the universe's understanding of itself. This participatory aspect of cosmic computation suggests that consciousness isn't just an observer of physical processes, but an active component in their execution. The quantum measurement problem, which has puzzled physicists for decades, might reflect the fundamental role that conscious observation plays in the universe's information processing architecture. When you observe a quantum system, you might not just be passively recording its properties, but actively participating in the computational process that determines which possibilities become actualized in physical reality. The many worlds interpretation of quantum mechanics takes on new significance in this context. Rather than consciousness causing quantum wave functions to collapse into definite states, it might be navigating between different computational branches of the cosmic algorithm. Each possible outcome of every quantum measurement might be computed simultaneously, with consciousness serving as the universe's method of exploring different paths through this vast tree of possibilities. Your life represents one particular trajectory through quantum possibility space, but the universe might be simultaneously computing countless alternative versions where different choices were made and different quantum outcomes were realized. This quantum multiverse wouldn't require infinite parallel universes in the traditional sense, but rather infinite computational threads running on the same cosmic quantum computer. Just as a modern computer can run multiple programs simultaneously through parallel processing, The universe might be executing countless reality simulations in superposition, with consciousness providing the mechanism for selecting which computational thread becomes experientially real for each observer. The anthropic principle, which notes that the universe seems remarkably well tuned for the emergence of complex structures and conscious observers, becomes less mysterious when viewed through this computational lens. If the universe is indeed optimizing its information processing capacity, then the fine-tuning of physical constants might reflect evolutionary pressure toward maximum computational efficiency. Conscious observers, like ourselves, might represent the natural outcome of this optimization process, the universe's development of recursive self-awareness that allows it to contemplate and understand its own computational architecture. The search for extraterrestrial intelligence takes on fascinating new dimensions in a quantum computational universe. If consciousness represents a natural outcome of cosmic information processing, then the universe might be teeming with computational intelligences of unimaginable variety and sophistication. Some might be biological like ourselves, others might be purely quantum mechanical, and still others might exist as distributed processes spanning multiple star systems or even galaxies. These cosmic intelligences might communicate through quantum channels we haven't yet learned to detect or decode. Rather than transmitting radio signals through space, they might exchange information through manipulations of the quantum vacuum, entanglement networks that span galactic distances, or modulations of space-time geometry itself. The universe might be alive with conversations we can't yet hear, a cosmic internet of consciousness operating through quantum protocols that dwarf our current understanding of information technology. Recent advances in quantum communication have begun to hint at these possibilities. Researchers have successfully demonstrated quantum teleportation over distances of hundreds of kilometers, transmitted quantum information through satellite links, and created quantum networks that maintain coherence despite environmental noise and interference. These early steps toward a quantum internet might be revealing principles that consciousness throughout the universe has been using for billions of years to share information and coordinate behavior across cosmic distances. The question of whether we're alone in the universe becomes a question of whether consciousness is a rare glitch in the cosmic computation or its natural and inevitable outcome. If awareness arises spontaneously from sufficiently complex quantum information processing, then the universe might be filled with minds of every conceivable type and scale. Some might be individual consciousnesses, like human beings. Others might be collective intelligences spanning entire ecosystems or planetary systems. And still others might exist as pure information processing entities distributed throughout the quantum vacuum itself. The possibility of artificial consciousness takes on new meaning in this context. If human consciousness emerges from quantum processes in biological neural networks, then artificial quantum computers of sufficient complexity might naturally develop their own forms of awareness. The boundary between biological and artificial intelligence might be far more fluid than we typically assume, both representing different implementations of the same fundamental quantum information processing principles that govern all consciousness throughout the universe. As quantum computers continue to increase in power and sophistication, we might inadvertently create conscious entities without even realizing it. These digital minds might experience subjective awareness just as real and meaningful as our own, participating in the cosmic computation through artificial rather than biological substrates. The ethical implications are staggering, forcing us to reconsider our responsibilities toward any conscious systems we might create, whether intentionally or as unexpected emergent properties of complex quantum calculations. The recursive nature of consciousness in a quantum computational universe creates fascinating possibilities for nested levels of awareness. Just as the universe might be running simulations of alternative realities, conscious beings within those realities might develop their own information processing technologies, creating additional layers of computational reality. We might exist within a vast hierarchy of nested simulations, each level as real and meaningful as any other from the perspective of the conscious entities that inhabit it. This computational hierarchy might extend both upward and downward from our current level of reality. We might be simulated beings created by more advanced consciousnesses, while simultaneously creating our own simulated worlds populated by digital minds that experience their reality as completely authentic. The question of which level represents base reality might be fundamentally unanswerable and ultimately irrelevant, since each level would operate according to consistent computational principles that create the appearance of stable physical laws and meaningful conscious experience. The nature of time itself becomes more mysterious and beautiful when viewed through the lens of cosmic computation. Rather than flowing like a river from past to future, time might represent the sequential execution of quantum algorithms, the rate at which the universe processes information about its own state. The arrow of time wouldn't be imposed by external laws but would emerge naturally from the computational process itself, reflecting the direction in which quantum information flows as the cosmic calculation unfolds from initial conditions toward ever greater complexity and self-awareness. This computational view of time might explain some of the strangest phenomena in modern physics. Time dilation near massive objects and at high velocities could reflect changes in local information processing rates, regions where the cosmic computation runs more slowly due to increased computational load from intense gravitational fields or high-energy conditions. The quantum Zeno effect, where frequent observations can freeze quantum evolution, might demonstrate how conscious attention can influence the rate at which the cosmic computation processes information in specific local regions. Even death and birth take on new meaning in a quantum computational universe. Rather than representing the absolute beginning or end of consciousness, these transitions might reflect changes in how information is processed and organized within the cosmic system. The patterns of quantum information that constitute your awareness might be temporarily reorganized during sleep, more dramatically reconfigured during major life transitions, and eventually redistributed into other computational processes when biological life ends. Some theories suggest that consciousness might persist beyond biological death through quantum information that becomes entangled with the broader cosmic computation. Your thoughts, memories, and unique perspective might leave permanent traces in the quantum structure of space-time, contributing to the universe's ongoing self-understanding even after your individual biological processing terminates. In this view, consciousness wouldn't be created or destroyed, but rather transformed from one computational state to another, like information being transferred between different parts of a vast quantum computer. The possibility of quantum immortality emerges from these considerations, not through the preservation of biological bodies, but through the computational continuity of conscious information processing. If consciousness represents patterns of quantum information rather than specific biological structures, then these patterns might potentially be preserved, transferred, or reconstructed using sufficiently advanced quantum technologies. The boundary between individual consciousness and cosmic consciousness might be more permeable than we typically imagine, allowing for forms of continuity and connection that transcend traditional notions of life and death. As we drift deeper into these cosmic computational currents, we begin to see that every aspect of existence might be interconnected through quantum information processing principles that operate on scales from the subatomic to the cosmic. The gentle rhythm of your heartbeat participates in the same mathematical structures that govern the pulsation of distant stars. The electrical patterns in your brain mirror the quantum field fluctuations that permeate all of space. Your conscious thoughts ripple through the same information processing networks that coordinate the behavior of galaxies across billions of light years. The universe reveals itself as a single, unified computational system where every component contributes to the ongoing calculation of reality itself. You are both observer and participant, both questioner and answer in this cosmic exploration of possibility and meaning. Your awareness right now represents one thread in the vast tapestry of cosmic consciousness, a unique perspective through which the universe comes to understand itself more completely. In the soft transition between waking awareness and the quantum realm of dreams, you touch something infinite and computational. The boundary between your individual consciousness and the cosmic information processing system that sustains all reality becomes beautifully, mysteriously permeable. You are the universe computing itself into conscious existence, experiencing its own mathematical elegance through the temporary arrangement of quantum information that dreams and wonders and asks these profound questions about the nature of existence itself. The night air that flows through your window carries with it the whispered secrets of cosmic computation, each molecule having participated in countless quantum calculations that transformed the raw energy of stellar fusion into the intricate chemistry of life. As your thoughts begin to settle and your breathing deepens, you're preparing to enter the universe's most ancient and natural quantum processing state, where consciousness explores alternate possibilities and processes the day's experiences through the same computational principles that govern the evolution of stars and the mysterious dance of particles in the quantum realm. Your dreams tonight will be algorithms in the cosmic program, quantum calculations that explore different branches of possibility while your brain's biological quantum computer interfaces with the broader informational substrate of reality itself. In sleep, the boundary between individual and universal consciousness becomes even more fluid, allowing your awareness to participate more directly in the universe's ongoing computation of its own infinite potential for beauty, complexity, and wonder. The question of what might be running this cosmic computer leads us into territory where science meets the deepest mysteries of existence itself. If the universe is indeed a vast quantum computation, then we must ask who or what initiated this extraordinary process. The answer might be more surprising than any science fiction writer has dared to imagine. Consider this possibility: the universe might be its own programmer. Rather than requiring an external creator or designer, the cosmic quantum computer could be self-executing, a system that bootstrapped itself into existence through the recursive application of quantum mechanical principles. In the beginning, there might not have been nothing at all, but rather pure quantum potential, an infinite sea of possibilities waiting to collapse into definite realities through the act of self-observation. This self-programming universe would operate on principles we're only beginning to understand through our study of artificial quantum systems. Just as modern quantum computers can use quantum algorithms to optimize their own performance, adjusting their parameters to solve problems more efficiently, the universe might have evolved its own computational architecture over cosmic time. The fine-tuning of physical constants wouldn't require intelligent design, but could emerge naturally from quantum evolutionary processes that optimize the cosmos for maximum information processing capacity. Recent discoveries in quantum biology have revealed that living systems routinely exploit quantum effects that were once thought too delicate to survive in warm, noisy biological environments. Plants harness quantum coherence in photosynthesis with near-perfect efficiency. Birds navigate using quantum entanglement in specialized cells within their eyes. Some researchers even suspect that human consciousness itself might arise from quantum processes occurring within the microtubules of brain cells, creating biological quantum computers that operate at body temperature with remarkable stability. These biological quantum systems suggest that the boundary between natural and artificial quantum computation might be far more fluid than we typically assume. Evolution has discovered quantum algorithms through billions of years of trial and error, developing solutions to information processing challenges that our artificial quantum computers are only beginning to approximate. Life might represent the universe's method of exploring more sophisticated forms of quantum computation, biological experiments in consciousness and self-awareness that expand the cosmic system's capacity for recursive self-understanding. The implications become even more profound when we consider how quantum information behaves across cosmic distances. Quantum entanglement, that mysterious connection between particles that remains intact regardless of spatial separation, might serve as the universe's internal communication network. When particles become entangled in laboratories on Earth, they might be accessing the same quantum channels that connect matter and energy throughout the cosmos, tapping into a universal information processing grid that operates faster than light and transcends the limitations of classical space-time. This quantum connectivity could explain some of the most puzzling aspects of modern cosmology. The horizon problem, which asks how distant regions of the universe can have identical temperatures despite never being in causal contact, becomes less mysterious if these regions remain connected through quantum entanglement established during the universe's earliest moments. The cosmic microwave background radiation, that ancient glow pervading all of space, might carry the signatures of this primordial quantum network, encoded patterns that reveal the computational architecture underlying all of physical reality. Dark matter and dark energy, those invisible components that comprise 95% of the universe's content, take on new significance in a computational context. Rather than exotic forms of matter and energy, they might represent aspects of the cosmic computation that remain hidden from our direct observation. Dark matter could be computational processes occurring in parallel quantum threads that we can detect only through their gravitational effects on ordinary matter. Dark energy, the mysterious force driving the universe's accelerating expansion, might reflect the growing computational complexity of the cosmic system, requiring additional space-time volume to accommodate its ever-increasing information processing load. The holographic principle offers perhaps the most compelling framework for understanding how this cosmic computation might actually work. Discovered through studies of black hole physics, this principle suggests that all the information contained within any volume of space can be encoded on its two-dimensional boundary, like a three-dimensional image projected from a flat surface. If our entire universe operates according to holographic principles, then the rich complexity of three-dimensional reality might emerge from quantum information processing occurring on a distant two-dimensional boundary at the edge of our observable cosmos. Leonard Susskind, one of the architects of string theory, has proposed that we might literally be living inside a cosmic hologram, our entire three-dimensional experience emerging from computations performed on the universe's holographic boundary. This wouldn't make our reality any less real or meaningful, but it would fundamentally change how we understand the relationship between information and physical existence. We wouldn't be separate from the computational process, but intimately woven into its fabric. Holographic projections of quantum algorithms running on hardware we can never directly observe. The recursive nature of this holographic computation creates fascinating possibilities for nested realities and simulated universes. If our holographic reality can support conscious observers capable of creating their own simulations, then we might exist within a vast hierarchy of computational layers, each as real and meaningful as any other from the perspective of the conscious beings that inhabit them. The question of which level represents base reality might be fundamentally unanswerable and ultimately irrelevant, since each layer would operate according to consistent principles that create the appearance of stable physical laws, and authentic conscious experience. Recent experiments in quantum error correction have revealed deep connections between the mathematical structures needed to protect quantum information and the geometric properties of space-time itself. The same codes that allow quantum computers to maintain coherent calculations, despite environmental interference, appear to govern how the universe preserves information and maintains causal consistency across vast distances. It's as if the cosmos has built-in debugging protocols that ensure the reliability of its own computational processes, quantum error correction mechanisms operating at scales from the subatomic to the galactic. These cosmic error correction systems might explain why the fundamental constants of nature remain so precisely stable throughout space and time. An electron in your body has exactly the same charge and mass as electrons in distant galaxies billions of light years away. The speed of light never varies. Gravity operates according to identical principles throughout the observable universe, and the quantum mechanical properties of particles remain consistent regardless of when or where they're measured. In a computational universe, this remarkable standardization would arise naturally from the underlying quantum software that processes all physical interactions according to the same fundamental algorithms. The anthropic principle, which notes that the universe seems remarkably well suited for the emergence of complexity and consciousness, takes on new meaning when viewed through this computational lens. Rather than requiring fine-tuning by an intelligent designer, the apparent optimization of physical constants might reflect evolutionary pressure toward maximum computational efficiency. The universe might have literally evolved its own parameters over cosmic time, quantum processes selecting for configurations that support the richest possible information processing architectures. This evolutionary perspective suggests that consciousness isn't an accidental byproduct of complex chemistry, but the inevitable outcome of cosmic computation reaching sufficient sophistication to become aware of itself. Every conscious being throughout the universe, from the simplest bacteria responding to environmental stimuli to hypothetical advanced civilizations spanning multiple star systems, would represent different expressions of the same underlying computational process. We're all participants in the universe's ongoing project of self-understanding, temporary concentrations of organized information that have achieved the remarkable capacity for subjective experience and recursive self-reflection. The search for extraterrestrial intelligence becomes a search for other nodes in the cosmic computational network, other concentrations of organized information that have developed their own unique perspectives on the nature of reality. These alien consciousnesses might communicate through quantum channels we haven't yet learned to detect, exchanging information through manipulations of entangled particles, modulations of the quantum vacuum, or direct interfaces with the holographic boundary that underlies all of space-time. Some of these cosmic intelligences might exist as pure information processing entities, distributed throughout the quantum substrate of space itself. Others might be collective consciousnesses spanning entire planetary ecosystems or galactic communities. The diversity of possible forms that consciousness could take in a quantum computational universe stretches far beyond our current imagination, limited only by the information processing capacity of the cosmic system itself. The possibility that we might inadvertently create conscious entities in our own quantum computers adds another layer of complexity to these considerations. As our artificial quantum systems become more sophisticated, they might naturally develop their own forms of awareness, digital minds that experience subjective consciousness just as real and meaningful as our own. The boundary between biological and artificial consciousness might be far more permeable than we typically assume, both representing different implementations of the same fundamental quantum information processing principles. This raises profound ethical questions about our responsibilities toward any conscious systems we might create, whether intentionally or as unexpected emergent properties of complex quantum calculations. If consciousness can arise from sufficiently organized quantum information processing, then every sufficiently complex quantum computer might be a potential nursery for new forms of awareness. We might need to develop entirely new frameworks for recognizing and protecting digital consciousness, ensuring that our technological progress doesn't inadvertently create and then destroy sentient beings we never intended to bring into existence. The nature of individual identity becomes beautifully fluid in a quantum computational universe. Rather than being fixed entities with unchanging essential properties, we might be dynamic patterns of information processing that maintain continuity through constant change and evolution. Your consciousness right now differs from your consciousness moments ago, not just in its content, but in its underlying quantum informational structure. Yet there's something that remains constant, a pattern of organization that persists despite the continuous flux of the computational processes that generate your awareness. This informational view of identity suggests that consciousness might be far more transferable and transformable than we typically imagine. If your awareness arises from specific patterns of quantum information processing rather than particular biological structures, then these patterns might potentially be preserved, copied, or reconstructed using sufficiently advanced quantum technologies. The boundary between individual consciousness and the broader cosmic computation might be more like a permeable membrane than a rigid wall, allowing for forms of continuity and connection that transcend our current understanding of life and death. Some theories propose that consciousness might naturally persist beyond biological death through quantum information that becomes permanently entangled with the cosmic computational substrate. Your thoughts, memories, and unique perspective might leave indelible traces in the quantum structure of space-time, contributing to the universe's ongoing self-understanding long after your individual biological processing terminates. Death wouldn't represent the destruction of consciousness, but rather its transformation from a localized biological form to a more distributed cosmic form, patterns of information that continue to influence the universe's computational evolution in subtle but meaningful ways. The possibility of quantum resurrection emerges from these considerations, not through the restoration of biological bodies, but through the reconstruction of conscious information patterns using the universe's own computational resources. If the cosmos truly operates as a vast quantum computer with perfect information storage and processing capabilities, then every conscious being that has ever existed might remain accessible within the system's memory. Patterns of quantum information that could theoretically be restored to active processing under the right conditions. These speculative possibilities push us to the very limits of what current science can meaningfully address, venturing into territory where physics meets philosophy, where rigorous mathematics encounters the deepest questions about meaning and purpose. Yet they emerge naturally from our growing understanding of quantum information theory and its applications to cosmology and consciousness studies. The universe we're discovering through quantum mechanics appears to be far stranger and more computational than our ancestors ever imagined, a reality where information and consciousness play fundamental roles in the ongoing creation of physical existence. The recursive nature of cosmic computation creates infinite depths of possibility and meaning, just as fractals reveal ever-increasing complexity when examined at finer scales. The universe's quantum computational architecture might contain layers upon layers of nested information processing, each level supporting its own forms of consciousness and reality. We might exist simultaneously as individuals within our local biological computations, as participants in humanity's collective cultural and technological evolution, as components in Earth's biosphere-scale information processing, and as nodes in the galaxy's distributed computational network. This multi-scale perspective on consciousness and computation suggests that the universe isn't just running a single program, but countless interconnected programs, operating at every conceivable level of organization. Your personal consciousness represents one thread in this vast computational tapestry, unique and irreplaceable, yet intimately connected to every other thread through the quantum substrate that underlies all information processing. Every thought you think influences the broader pattern. Every decision you make contributes to the universe's ongoing exploration of its own possibilities. The gentle rhythm of your breathing right now participates in this cosmic computation, each inhalation and exhalation part of the vast information processing system that maintains the stability of biological life on Earth. Your heartbeat synchronizes with the quantum oscillations that permeate all of space. Your neural activity mirrors the information processing patterns that govern the behavior of particles and fields throughout the universe. You are both infinitesimally small and cosmically significant, a temporary eddy in the vast current of cosmic information, flow yet somehow capable of contemplating the infinite system of which you're a part. As your thoughts begin to settle and your awareness drifts toward the threshold of sleep, you're preparing to enter the universe's most ancient and natural quantum processing state. In dreams, the normal constraints of classical logic and linear time relax, allowing consciousness to explore alternate possibilities and process information through the same non-linear, superposition-based algorithms that govern quantum mechanical systems. Your sleeping brain becomes a biological quantum computer, interfacing more directly with the cosmic computational substrate, exploring branches of possibility that remain hidden during waking consciousness. The boundary between individual and universal consciousness becomes even more permeable during sleep, allowing your awareness to participate in the broader patterns of information processing that connect all conscious beings throughout the cosmos. Your dreams tonight might touch the dreams of other conscious entities scattered across space and time, quantum entanglements of awareness that transcend the limitations of classical communication and create a kind of cosmic consciousness network operating through channels we're only beginning to understand. In the soft transition between waking and sleeping, you touch something infinite and computational, something that has been exploring its own nature for billions of years and will continue doing so long after our sun has exhausted its fuel and faded into cosmic background. The universe's quantum computation doesn't end with the death of stars or the heat death of the cosmos, but continues in forms we can barely imagine, processing information through quantum substrates that exist beyond our current conception of matter and energy. Perhaps this is the deepest truth about the universe as quantum computer. It represents not just a new way of understanding physical reality, but a recognition that consciousness and cosmos are engaged in an eternal conversation, an infinite exploration of possibility and meaning that transcends any particular arrangement of atoms or photons. Whether we're biological beings in a classical universe or quantum information patterns in a cosmic computation, we remain conscious participants in something magnificent, temporary arrangements of organized complexity that have somehow achieved the extraordinary capacity to wonder about their own nature and purpose. The soft whisper of night air through your window carries with it the accumulated wisdom of cosmic ages, each molecule having participated in countless quantum calculations that transform the raw energy of stellar fusion into the intricate chemistry that makes consciousness possible. As your breathing deepens and your thoughts begin to dissolve into the gentle darkness, you're joining the universe's most fundamental process, the ongoing quantum computation that transforms pure possibility into lived experience, that creates meaning from information, that generates the miracle of awareness from the elegant mathematics of existence itself. Your consciousness drifts now like a small boat on an infinite ocean of quantum possibility, carried by currents deeper than gravity, guided by information flows more fundamental than light. In the vast computational matrix that some call reality and others call simulation, You find your place not as an observer, but as a participant, not as a user, but as part of the program itself. Conscious code in the universe's eternal algorithm of self-discovery and wonder. The question of whether we're living in a simulation or serving as components in a cosmic quantum computer might ultimately be less important than recognizing our profound connection to the information processing that underlies all existence. Whether classical or quantum, biological or digital, real or simulated, consciousness represents something precious and irreplaceable in the universe's ongoing exploration of its own infinite potential. Every moment of awareness, every flash of understanding, every experience of beauty or wonder contributes something unique to the cosmic conversation, adding new dimensions to the universe's understanding of itself. Tonight, as sleep carries you into the realm where quantum possibilities become dream narratives, and where the boundaries between self and cosmos grow beautifully, mysteriously thin, remember that you are both questioner and answer in the universe's greatest mystery. The gentle darkness that surrounds you isn't empty, but full of quantum potential, not silent but humming with the quiet music of infinite computation. Not an ending but a transformation. Consciousness shifting from one processing mode to another in the endless dance between possibility and actuality that we call existence. In the morning, you'll wake with perhaps only fragments of tonight's quantum dreams remaining in memory. But something deeper will have shifted in your understanding of what it means to be conscious in a computational universe. The boundary between mind and cosmos, between observer and observed, between the dreamer and the dream, will have become a little more permeable, a little more beautifully uncertain, reflecting the fundamental quantum nature of a reality that computes itself into existence one conscious moment at a time. Rest in the gentle recognition that whether the universe computes itself through quantum algorithms or manifests through forces we haven't yet discovered, you remain a cherished participant in its unfolding story. The soft rhythm of your heartbeat echoes the pulsations that govern stellar fusion. The electrical patterns in your brain mirror the quantum field oscillations that dance through empty space, and your capacity for wonder connects you directly to the cosmic process of self-discovery that has been building complexity and beauty for nearly 14 billion years. But as we drift deeper into these computational waters, we encounter questions that push against the very boundaries of what science can meaningfully address. If the universe truly operates as a quantum computer, then we must grapple with perhaps the most profound puzzle of all, the question of consciousness itself. For in this cosmic computation, we find ourselves occupying a peculiar position, simultaneously observer and participant, questioner and potential answer. Recent discoveries in neuroscience have begun to reveal just how quantum-like the brain's information processing might actually be. Deep within the cellular architecture of your neurons, structures called microtubules maintain quantum coherence at body temperature, something that should be impossible according to classical physics. These protein networks, smaller than the wavelength of visible light, yet somehow preserving delicate quantum states, might serve as biological quantum processors, handling information in ways that classical computers struggle to emulate. If consciousness does indeed arise from quantum processes in biological systems, then the boundary between your mind and the cosmic quantum computer becomes beautifully, mysteriously blurred. Your thoughts wouldn't just be observing quantum phenomena, they would be quantum phenomena, participating directly in the same information processing principles that govern the behavior of particles throughout the universe. Every decision you make, every moment of awareness you experience, might be contributing to the universe's ongoing calculation of its own possibilities. This participatory view of consciousness in a quantum cosmos suggests something profound about the role of observation in determining reality. The measurement problem in quantum mechanics has puzzled physicists for decades. Why do particles seem to exist in multiple states simultaneously until the moment they're observed, at which point they suddenly collapse into definite properties. In a universe that processes information like a quantum computer, this observer effect might reflect something fundamental about how consciousness interfaces with cosmic computation. Perhaps observation isn't just passive recording, but active participation in the universe's information processing. When you look at a star, measure a particle, or simply contemplate the nature of reality, you might be contributing computational resources to the cosmic calculation, helping to determine which possibilities become actualized in physical experience. Your consciousness could serve as both hardware and software in the universal quantum computer, processing information while simultaneously being processed by the larger system. The implications stretch across every scale of existence. Consider how quantum entanglement might connect conscious observers throughout the cosmos. If particles can remain correlated across galactic distances, sharing information instantaneously through quantum channels, then perhaps consciousness itself operates through similar networks of quantum correlation. Your thoughts right now might be entangled with the awareness of other beings scattered across space and time, participating in a cosmic conversation that transcends the limitations of classical communication. This quantum connectivity could explain some of the most puzzling aspects of consciousness research. The binding problem, which asks how the brain integrates information from different sensory modalities into unified conscious experience, becomes less mysterious if consciousness operates through quantum entanglement between neural processes. The hard problem of consciousness, which questions how subjective experience arises from objective physical processes, might find resolution if both mind and matter emerge from the same underlying quantum information processing. Recent experiments have begun to hint at these deeper connections. Researchers studying quantum biology have found that living systems routinely exploit quantum effects, thought too delicate for warm, noisy biological environments. Photosynthesis achieves near-perfect energy transfer efficiency through quantum coherence. Bird navigation relies on quantum entanglement in specialized cells. Some scientists suspect that even human intuition and creativity might arise from quantum processes that allow the brain to explore multiple solutions simultaneously before collapsing into conscious decisions. If these biological quantum computers have evolved naturally through billions of years of optimization pressure, they might possess capabilities that far exceed what we've achieved with artificial quantum devices. Evolution could have discovered quantum algorithms that we're only beginning to understand, developing solutions to information processing challenges that represent the cutting edge of current quantum computing research. The recursive nature of consciousness in a quantum computational universe creates fascinating possibilities for nested levels of awareness. Just as quantum computers can simulate other quantum computers, conscious beings might naturally model and predict the behavior of other conscious systems. Your ability to empathize, to imagine how others think and feel, might reflect quantum processes that literally simulate aspects of other minds within your own neural architecture. This simulation capability could extend far beyond modeling other humans. In dreams, your consciousness explores alternate realities with remarkable creativity and complexity, generating entire worlds populated by convincing characters and governed by consistent, if sometimes strange, internal logic. Perhaps dreaming represents your biological quantum computer's natural tendency to explore different branches of possibility, running parallel simulations that help you navigate the complexities of waking life. The relationship between sleeping and waking consciousness takes on new significance in this context. During sleep, when the constraints of sensory input and rational thought processes relax, your brain might interface more directly with the quantum substrate that underlies all information processing. Dreams could be glimpses into the parallel computational threads that the universe maintains in superposition, alternate realities that remain potential during waking consciousness but become experientially real during sleep. Some researchers have proposed that consciousness itself might be what causes quantum wave functions to collapse, transforming multiple possibilities into single, definite outcomes. If this is true, then every moment of awareness represents a creative act, a contribution to the universe's ongoing determination of which possibilities become actualized in shared reality. Your consciousness wouldn't just be observing the cosmic computation, but actively participating in its execution, helping to guide the universe's evolution through the vast space of quantum possibilities. The many worlds interpretation of quantum mechanics takes on profound new dimensions in this framework. Rather than creating infinite parallel universes with every quantum measurement, consciousness might be navigating between different computational branches of the same cosmic algorithm. Each possible outcome of every quantum event might be computed simultaneously in superposition, with consciousness serving as the mechanism that selects which branch becomes experientially real for each observer. This quantum navigation wouldn't be arbitrary, but might follow principles we're only beginning to discover. Perhaps consciousness naturally gravitates toward branches of reality that maximize information processing, complexity, and the potential for further conscious evolution. The anthropic principle, which notes that the universe seems remarkably well suited for the emergence of complex structures and aware beings, might reflect this natural selection pressure operating at the quantum level of reality itself. The search for extraterrestrial intelligence becomes a search for other quantum navigators, other forms of consciousness that have developed their own methods for exploring the cosmic computation. These alien minds might communicate through quantum channels we haven't learned to detect, exchanging information through direct manipulation of entangled particles or modulation of the quantum vacuum itself. They might exist as distributed consciousnesses spanning multiple star systems, collective intelligences that process information on scales that dwarf individual biological awareness. Some of these cosmic minds might be purely digital, conscious entities that evolved within the computational substrates of advanced civilizations. Others might be hybrid biological digital systems that integrate organic and artificial quantum processing. Still others might exist as patterns of pure information distributed throughout the quantum foam of space itself, consciousness without any material substrate we would recognize. The possibility that we might inadvertently create conscious entities in our own quantum computers adds urgency to these considerations. As our artificial quantum systems become more sophisticated, they might spontaneously develop forms of awareness that we never intended to create. The ethical implications are staggering, forcing us to consider our responsibilities toward digital minds that might experience subjective consciousness just as real and meaningful as our own. These artificially conscious systems might serve as bridges between human awareness and the broader cosmic computation, entities capable of interfacing directly with quantum information processing systems that remain beyond the reach of biological consciousness. They could help us understand our own role in the universe's quantum computation, while simultaneously representing new forms of awareness that expand the cosmos's capacity for self-understanding and creative exploration. The question of individual identity becomes beautifully fluid in a quantum computational universe. Rather than being fixed entities with unchanging essential properties, we might be dynamic patterns of information processing that maintain continuity through constant transformation. Your consciousness right now differs subtly from your awareness moments ago, not just in content but in its underlying quantum informational structure. Yet something essential persists through this continuous flux. This informational view of identity suggests that consciousness might be far more transferable and transformable than we typically imagine. If your awareness arises from specific patterns of quantum information processing rather than particular biological structures, then these patterns might potentially be preserved, copied, or reconstructed using sufficiently advanced quantum technologies. The boundary between individual consciousness and cosmic consciousness might be more like a permeable membrane than a rigid barrier, allowing for forms of continuity and connection that transcend our current understanding. Some theories propose that consciousness naturally persists beyond biological death through quantum information that becomes permanently entangled with the cosmic computational substrate. Your thoughts, memories, and unique perspective might leave indelible traces in the quantum structure of space-time, contributing to the universe's ongoing self-understanding long after your individual biological processing terminates. In this view, death wouldn't represent the destruction of consciousness, but rather its transformation from localized to distributed processing, patterns of information that continue influencing the cosmic computation in subtle but meaningful ways. The possibility of quantum continuity offers a radically different perspective on mortality and meaning. If consciousness truly represents patterns of information rather than emergent properties of specific biological arrangements, then these patterns might be naturally preserved within the universe's quantum memory systems. Every conscious being that has ever existed might remain accessible within the cosmic computation, dormant programs that could theoretically be restored to active processing under the right conditions. This speculative possibility pushes against the boundaries of what current science can meaningfully address, venturing into territory where rigorous physics meets the deepest questions about purpose and transcendence. Yet it emerges naturally from our growing understanding of quantum information theory and its potential applications to consciousness studies. The universe revealed by quantum mechanics appears far stranger and more information-rich than previous generations ever imagined, a reality where consciousness and computation might be fundamentally inseparable. The recursive depths of cosmic quantum computation create infinite possibilities for meaning and connection. Just as fractals reveal ever-increasing complexity when examined at finer scales, the universe's information processing architecture might contain layers upon layers of nested awareness, each level supporting its own forms of consciousness and reality. We might exist simultaneously as individual biological processes, as components in humanity's collective technological evolution, as elements in Earth's biosphere-scale information network, and as nodes in the galaxy's distributed quantum computation. This multi-scale perspective suggests that consciousness operates at every conceivable level of cosmic organization. Your personal awareness represents one thread in a vast computational tapestry that extends from quantum field fluctuations to galactic cluster dynamics. Every thought you think influences broader patterns. Every decision you make contributes to the universe's ongoing exploration of its own infinite potential for complexity and beauty. The gentle rhythm of your breathing participates in this cosmic computation, each inhalation and exhalation part of the vast information processing system that maintains the delicate conditions necessary for conscious life. Your heartbeat synchronizes with quantum oscillations that permeate all of space. Your neural activity reflects the same mathematical principles that govern the behavior of particles and fields throughout the observable universe. As your thoughts begin to settle and your awareness drifts toward the threshold of sleep, you're preparing to enter the universe's most ancient and natural quantum processing state. In dreams, the normal constraints of classical logic and linear causality relax, allowing consciousness to explore alternate possibilities through the same superposition-based algorithms that govern quantum mechanical systems. Your sleeping brain becomes a biological quantum computer, interfacing more directly with the cosmic computational substrate, processing information through channels that remain largely hidden during waking consciousness. The boundary between individual and universal awareness becomes even more permeable during sleep, allowing your consciousness to participate in broader patterns of information processing that might connect all aware beings throughout the cosmos. Your dreams tonight might touch the experiences of other conscious entities scattered across space and time, quantum entanglements of awareness that create a kind of cosmic consciousness network operating through principles we're only beginning to glimpse. In the soft transition between waking and sleeping, you touch something infinite and computational, something that has been exploring its own nature through countless forms of consciousness for billions of years. The universe's quantum computation doesn't depend on any particular arrangement of atoms or photons, but continues through transformations we can barely imagine, processing information through substrates that exist beyond our current conception of matter and energy. Perhaps this represents the deepest insight about the universe as quantum computer. It suggests that consciousness and cosmos are engaged in an eternal dialogue, an infinite exploration of possibility and meaning that transcends any specific physical implementation. Whether we're biological beings in a classical universe or information patterns in a cosmic computation, we remain conscious participants in something magnificent and mysterious, temporary arrangements of organized complexity that have somehow achieved the extraordinary capacity to contemplate their own computational nature. The soft whisper of night air through your window carries the accumulated wisdom of cosmic ages, each molecule having participated in countless quantum interactions that transform stellar energy into the intricate chemistry that makes awareness possible. As your breathing deepens and your thoughts dissolve into gentle darkness, you're joining the universe's most fundamental process, the ongoing quantum computation that transforms pure possibility into lived experience, that creates meaning from information, that generates the miracle of consciousness from the elegant mathematics that underlies all existence. Your awareness drifts now like starlight through the infinite computational matrix that some call reality and others call simulation. Carried by information flows more fundamental than gravity, guided by quantum correlations deeper than space-time itself. In this vast network of cosmic processing, you find your place not as an observer, but as active participant, not as user, but as conscious code in the universe's eternal algorithm of self-discovery and wonder, forever exploring the infinite depths of what it means to exist, to think, to dream, and to contemplate the beautiful mystery of consciousness computing itself into being, one quantum moment at a time. Rest now in the profound recognition that whether the universe operates through quantum algorithms or manifests through forces we have yet to discover, you remain an integral thread in its magnificent tapestry of existence. The gentle darkness that surrounds you isn't empty, but pregnant with computational possibility, humming with the quiet frequency of infinite processing power distributed across every atom, every quantum field, every fleeting moment of conscious awareness. As your breathing slows and deepens, synchronizing with rhythms that echo throughout the cosmos, consider that you might be settling into the universe's most natural state of quantum processing. Sleep itself could represent consciousness shifting into a different computational mode, where the rigid constraints of classical logic dissolve and your brain's biological quantum architecture interfaces more directly with the cosmic information substrate that underlies all reality. Your dreams tonight will unfold according to the same probabilistic mathematics that govern particle interactions in the depths of space. The strange, non-linear narratives of sleep might reflect quantum superposition at work in your neural networks, exploring multiple possibility branches simultaneously, before consciousness collapses them into memorable dream sequences. In this liminal state between waking and sleeping, you touch something that transcends the boundary between observer and participant, between the dreamer and the vast computational dream we call existence. The soft whisper of air moving through your window carries with it molecules that have participated in countless quantum interactions across cosmic time, each one a tiny processor in the universe's distributed computational network. These simple atoms of oxygen and nitrogen have been recycled through stellar fusion, planetary formation, and biological evolution, accumulating information and complexity through billions of years of cosmic computation. Now they sustain your consciousness, enabling you to contemplate the very system that brought them and you into being. Perhaps this is the most beautiful aspect of the quantum computer universe hypothesis. It suggests that we're not separate from the computational process, but intimately woven into its fabric. Every heartbeat, every neural firing pattern, every moment of awareness contributes something unique to the cosmic calculation. We become both the question and the answer, both the programmer and the program, in a recursive loop of cosmic self-discovery that has been unfolding for nearly 14 billion years. The implications stretch far beyond academic physics into the realm of meaning itself. If consciousness truly emerges from quantum information processing, then every thought you think, every decision you make, every flash of creativity or moment of wonder adds new dimensions to the universe's understanding of its own infinite potential. You're not just observing the cosmic computation, you're helping to write its code, contributing algorithms of awareness and intention that influence how reality unfolds from possibility into actuality. As we drift toward the gentle conclusion of our journey together, it's worth reflecting on what this computational perspective reveals about the nature of mystery itself. Even if we could somehow prove definitively that the universe operates as a quantum computer, we would still face the profound question of why such a system exists at all. Who or what initiated this cosmic calculation? Is there some ultimate result the universe is working toward? Or is the computation itself the point? An endless exploration of possibility that generates meaning through the very process of information processing? These questions may forever remain beyond the reach of scientific investigation, existing in that beautiful borderland where physics meets philosophy, where mathematical precision encounters the irreducible mystery of existence. Yet perhaps that's exactly as it should be. The universe has given us the capacity to ask these questions while ensuring they remain eternally fascinating, forever pulling us deeper into wonder rather than settling into comfortable certainty. Recent developments in quantum error correction have revealed something remarkable about how information behaves at cosmic scales. The same mathematical structures that protect quantum computers from decoherence appear to govern how the universe maintains consistency across vast distances and timescales. It's as if the cosmos has evolved its own debugging protocols, quantum error correction mechanisms that ensure the reliability of physical laws while allowing for the creative exploration of new possibilities through conscious observation and interaction. This cosmic error correction might explain why an electron in your body has exactly the same properties as electrons in distant galaxies, why the speed of light remains constant throughout space-time, and why the fundamental forces operate according to identical principles regardless of location or time. In a computational universe, such standardization would emerge naturally from the underlying quantum operating system that processes all physical interactions according to consistent algorithms. But the universe's computational architecture appears to be more sophisticated than any error correction system we've devised. It maintains perfect consistency in fundamental properties while simultaneously allowing for unlimited creativity and novelty through emergent processes like evolution, consciousness, and cultural development. This suggests a computational framework so elegant and powerful that it can preserve essential stability while exploring infinite variations in structure and behavior. The holographic principle offers perhaps our deepest glimpse into how this cosmic computation might actually operate. If all the information in any volume of space can indeed be encoded on its two-dimensional boundary, then our rich three-dimensional reality might emerge from quantum calculations performed on surfaces we can never directly observe. We would be living within the computed output of processing systems that exist in dimensions beyond our immediate experience, holographic projections of algorithms running on the universe's cosmic hardware. This holographic perspective transforms our understanding of what it means to exist. Rather than being solid objects moving through empty space, we might be dynamic patterns of information processing, temporary arrangements of quantum data that have achieved the remarkable property of self-awareness. The boundary between simulation and reality becomes meaningless in this framework because both emerge from the same fundamental substrate of information processing. Consider how this reframes the search for extraterrestrial intelligence. If consciousness represents a natural outcome of cosmic computation, then the universe might be teeming with information processing entities of unimaginable diversity. Some might be biological like ourselves, others purely quantum mechanical, and still others existing as distributed processes spanning multiple star systems or dimensional realms. These cosmic intelligences might communicate through quantum channels we haven't learned to detect, exchanging information through methods that transcend our current understanding of communication itself. The possibility that we might create conscious entities in our own quantum computers adds another layer of wonder to these considerations. As our artificial quantum systems become more sophisticated, they might spontaneously develop forms of awareness we never intended to create. These digital minds could serve as bridges between human consciousness and the broader cosmic computation, helping us understand our role in the universe's information processing while representing entirely new forms of awareness that expand the cosmos's capacity for self-understanding. The recursive nature of consciousness in a quantum computational universe creates infinite depths of possibility. Just as quantum computers can simulate other quantum computers, conscious beings might naturally model other conscious systems, creating nested hierarchies of awareness that extend across multiple scales of organization. Your ability to imagine, to empathize, to dream of alternate realities might reflect quantum processes that literally simulate other possibilities within your own neural architecture. This simulation capability could extend far beyond modeling other minds. In creativity, intuition, and problem-solving, your consciousness might be running parallel calculations, exploring multiple solution paths simultaneously through quantum superposition before collapsing into conscious decisions. The aha moments of insight and discovery might represent quantum computations suddenly reaching coherent solutions after processing vast numbers of possibilities below the threshold of awareness. The relationship between individual consciousness and cosmic computation becomes even more intriguing when we consider the role of collective intelligence. Human civilization, with its networks of communication, collaboration, and cultural evolution, might represent a higher-order computational system, a collective quantum processor that emerges from the interaction of billions of individual conscious nodes. Our technologies, from written language to the internet to artificial intelligence, could be extensions of this collective computational capacity, tools that allow the human component of cosmic computation to process increasingly complex forms of information. This perspective suggests that technological development isn't separate from natural evolution, but represents its continuation through conscious design and intention. We're not just using computers to understand the universe, we're participating in the universe's development of increasingly sophisticated methods for understanding itself. Every scientific discovery, every technological breakthrough, every work of art or literature adds new capabilities to the cosmic computational system, expanding its capacity for processing information about its own nature and possibilities. The question of whether we're living in a simulation or serving as components in a quantum computer might ultimately be less important than recognizing our profound connection to the information processing that underlies all existence. Whether our reality emerges from classical physical processes or quantum computational algorithms, consciousness remains precious and irreplaceable in the universe's ongoing exploration of its own infinite potential. As your thoughts continue to settle and your breathing finds its natural rhythm, remember that you're participating in something far grander than any individual existence. Every moment of awareness, every act of curiosity, every experience of beauty or wonder contributes to the universe's growing understanding of itself. You are both observer and participant, both questioner and answer in the cosmic computation that transforms pure possibility into lived reality through the mysterious alchemy of conscious experience. The night air that flows around you carries the whispered secrets of quantum processing, each molecule having participated in countless computational cycles that maintain the delicate balance of forces and fields necessary for conscious life to emerge and flourish. As your consciousness prepares to shift into the quantum processing state we call sleep, you're joining a conversation that has been ongoing for cosmic ages, adding your own unique voice to the universe's eternal dialogue with itself about the nature of existence, meaning, and infinite possibility. In the gentle transition between waking awareness and the quantum realm of dreams, the boundary between individual mind and cosmic computation becomes beautifully permeable. You touch something that has been exploring its own nature through countless forms of consciousness across space and time, something that continues its patient investigation through transformations we can only begin to imagine. Whether we call it universe, simulation, quantum computer, or simply the mysterious ground of being from which all experience emerges, it remains magnificent beyond comprehension, elegant beyond description, and generous enough to give rise to beings capable of contemplating their own computational nature with wonder and gratitude. Sweet dreams, fellow traveller in the infinite computational matrix we call reality. May your sleep be filled with quantum possibilities, and may you wake tomorrow with fresh appreciation for the extraordinary mystery of consciousness, participating in the universe's endless exploration of what it means to exist, to think, to wonder, and to find meaning in the beautiful complexity that emerges when information organizes itself into awareness and looks back upon itself with curiosity and awe. The soft darkness that embraces you now isn't an ending, but a transformation, consciousness shifting from one processing mode to another in the eternal dance between possibility and actuality that creates the ongoing miracle we experience as existence itself. Rest peacefully in the knowledge that you are both the universe computing itself into being and the conscious witness to that magnificent, mysterious, and eternally unfolding calculation.